Today we are going to continue from last time and continue with the second rule, which is the derivative of ln of x is equal to 1 over x. So I'm going to prove this rule using two methods. So let's start with the first one. Here we have method 1. Method 1 is a fairly simple one. So we first start with equating y equal to ln of x. And basically what we want to find is dy dx. Because that's basically the derivative of y, which is the derivative of ln of x, right? So, but then if you directly take derivatives of both sides of the equation, you'll realize that you get nothing useful. So what we're going to do is we are going to put y and ln of x on the exponent of e. So here we have e to the y power is equal to e to the ln of x powered, okay? And simplifying this equation, we get e to the y powered is equal to x, okay? Now we can sort of take the derivatives of the both side and see what we get. So the derivative of the left-hand side of the equation, as we just proved, the derivative of e of x is equal to e of x itself. So the left-hand side of our equation is basically e to the x powered times dy dx. And the right-hand side is simply 1 because the derivative of x is equal to 1. Now, isolating dy dx, we get dy dx is equal to 1 over e to the y powered. And now notice that we defined e to the y powered equal to x, okay? So basically we can substitute x into our equation. Therefore, we get dy dx is equal to 1 over e to the x, e to the y powered, which is equal to 1 over x. And thus we have proven our rule using the first method. Okay, so now let's prove this again using method 2, which we are going to take an advantage of the definition of derivatives again. So here we have method 2, and using the definition of the derivatives, so by the definition of derivatives, so I'm gonna write the definition of derivatives one more time right here. Definition of derivatives right here, which we have f prime of x is equal to limit as h approaches 0 of fx plus h minus f of x over h. Okay. Now, by the definition of derivatives, we have that the derivative of ln of x is equal to limit as h approaches 0. On the numerator, we have ln x plus h minus ln x. And on the denominator, we have h. Now, using the property of logarithmic functions, we can sort of simplify this limit into something like this. So let's first isolate the 1 over h. So let's put it right here, 1 over h times. So basically the numerator turns into ln x plus h divides x. Okay, this is a crucial property of the logarithmic function where ln a minus ln b is basically ln a divides b in the brackets. Okay, now again using the property of logarithmic functions, we can further simplify this expression into limit as h approaches 0, ln 1 plus, let's just simplify this inside the brackets, h over x, and then we have exponent 1 over h, okay? So also let me just write this rule here so that everything's 100% clear. So if we have ln a times ln b, let's not say ln, let's say a times log b c. This is equal to log b c to the eighth power, okay? And similarly here, the rule here is that if we have ln a minus ln b, this is basically equal to ln a divided by b, okay? Okay, now getting back to our expression, now what we can do is that we can let, okay, t equal to h over x. Therefore, we can get limit as h approaches 0, ln, inside we have 1 plus t. And because h, by this expression, h is equal to t times x, on the exponent, we have 1 over t times x, okay? Now, again, using the property of logarithmic functions, we can further simplify this, and we can sort of put this 1 over x down. So let's sort of put this 1 over x right here, and then times ln h approaches 0 of ln 1 plus t over 1 to the 1 divided by t powered. And now, if you're really familiar with the number e, then you'll immediately realize that this thing right here is exactly the same as the definition of e. So here I'm going to write I'm going to state the definition of e. So the definition of e is that limit as x approaches 0, 1 plus 1 plus x, or 1 to the 1 divided by x, is powered is equal to e. Okay? And so by the definition of e, we'll realize that we have this thing right here, okay? So this is exactly the same as the definition of e. And we know this because when h is approaching 0, that means t is also approaching 0 because t is equal to h over x. So we can basically change this h into t. And this will turn this exactly the same as the definition of e. And therefore, we can transform this into 1 over x times limit. Well, no. After transformation, we get ln e. Because we can substitute this e into our expression. And this is our answer. And what's ln e? Ln e is 1. So basically, we get 1 divided by x times 1, which is 1 divided by x. And thus, we have proven a rule using method 2. So in the next video, I will prove just one more rule, which is that the derivative of a to the x powered is equal to a to the x powered times ln a. So I hope you enjoyed today's video.